in this scenario, because the bullet hits the block and they stick together, it's an inelastic collision. Okay, so we're going to need to kind of set ourselves up here. There's a table for me to use over here, and I'll pull it up. Here's how we're going to set this up. You're going to have, we have one column. Doesn't want to go anywhere yet. There we go. The last column is our after column. First column is before. Okay. Now, and the bottom row is our total. I'll make this a bit bigger so we can see it just a little bit better. Okay. And anything that we're dealing with, we're going to primarily use this equation for each individual piece. Now, I could write these down as object 1 and object 2, but honestly, if it's a bullet and a block, I'm going to call them what they are. Bullet, block. Now, the idea for what we're doing here is we're going to add up our two before columns, and that'll give us the total before. We're going to start with that. So in the beginning, there was give me a second here, a 0.05 kilogram block, and it was multiplied that by a velocity of 100. Let me make ourselves a little bit more space. Okay. Multiply those two together, we get 5. Now our other one, though it's a 5 kilogram block, but it's at rest. So it has a momentum of 0. If I add those two things together, I end up with a momentum of 5 kilogram meters per second. All right, so that's our before side. We just take each individual piece, find the momentum, add them up. We're going to do the same basic idea. On the other, we're going to take the two after amounts. We're going to add them up, and that'll give us our total. All right, so afterwards, well, actually, let's think about this one. Okay, I have the masses, right? But I don't have a number for the velocity. So if you don't have a number, what we're going to do is we're going to put in a variable. Now, let's think about this. If the bullet hits the block and they stick together, what does that say about the velocity of each object? They got to be the same thing. So I don't have to do like a V1 and a V2. It's just V because they're the same. So I'm going to write down, I'm going to take my mass, and I'm going to multiply it by my velocity. I don't know what the number is, so I just put in a variable. I'm going to do the same thing for the other side. I've got a velocity, a mass of 5, and it's going to be the same velocity as my other object because the two objects hit and they stick together. When I add these guys up, I get 5.05 times the velocity. Okay. Now what conservation of momentum tells us is that these two things have to equal each other, right? So from this point on, we're just doing math. I'm going to solve for V. Divide both sides by 5.05. That cancels out. And I'm left with V is equal to 0.99 meters per second. What we're saying when we do that is if I were to take over there on the right-hand side that 5.05 and I multiply that by 0.99, that's going to be 5. Because both of these boxes on the bottom have to be the same value. Anything I like? Oh, yes. Okay. So object 1 was 0.05 kilograms, right? And object 2 was 5 kilograms. That's about, the second object is basically 100 times bigger than the first object. Okay. Now, and by chance, our initial velocity was 100. Okay. So let's take a look. What happens to our velocity when our mass increases by 100%. Okay, so if our mass increases by 100, our velocity decreased by 100% as well, all the way down to upper right-hand corner, 0.99 meters per second. That's kind of that inverse relationship, mass and velocity. Okay, that's our first example. Let's go to our next one. And I'm going to need something to do. There we go. Too far, wrong way. There we go. May I please have a volunteer named Raiden? Volunteer, voluntold. Could you read the story first, please?
Two pool balls colliding perfectly in elastic collision as shown below. What is the velocity of each after the collision?
Okay, so this makes, okay, fine. It's an inelastic collision. Why does this hurt my head a little bit? No, honestly, it's a wording thing. It's not even a, it's just a wording in the problem. What's the inelastic collision again? When they stick. What do pool balls do? All right.
They're covered in glue, Mrs. Swan.
That's what I'm saying. We're going to pretend they're like Play-Doh pool balls, all right? So we're just going to pretend, because if I don't fix this, if I don't change this little bit of a wording in here, it's going to hurt my head. Because pool balls do not stick together. So they're Play-Doh pool balls. Okay, so same principle, same principle. You're going to make a table. And in this table, let me clear some things out so we can get rid of a few things. So we're going to start over here. Yeah, I'll get rid of that. And they're not the bullet and the block anymore, so we'll have to come over to that. And I'm going to make this big again, so we can see it. So you guys get yourself set up. I'll get myself set up. Okay. Now this time, like I said, they're not obviously different objects. So I'm, like bullet and a block. I'm going to call this one object 1. The one on the left, I'm going to call the one on the right object 2. And I'm going to label my stuff down here as object 1 and object 2. Okay. And remember, the big idea is that we take each individual momentum and we add them up, and that's going to give us our total. So if I take both the momentums beforehand, I add those up, it'll give me a momentum after the momentum before. So in this case, we've got 1.5 kilograms times 10 meters per second, and that gives us 15 kilogram meters per second. All right, the other object is 1 kilogram. Hang on, there we go. Is 1 kilogram, and it's multiplied by 20 meters per second. What? Well, not me? No. It adds up to 35. Whoa, not that. Okay. Is this right?
Yeah.
Take a good look. Is this right? This slightly awkward pause that's growing longer and longer is a small clue that maybe not everything is right. Which direction? We're still on before. The one going to the left? What about it? It should be negative, right? Yeah, because velocity is a vector and so is momentum. So that means we end up with positive 15 plus negative 20. So we ended up with a flat out negative 5. So what does that tell us? When we have two objects that are coming at each other, generally speaking, your momentum is going to decrease. Okay, so there's our before. Let's do the same thing on our after. Find each individual one, add them up, and go from there. Now, in this case, it was an inelastic collision. So what do we do with the velocity if it's an inelastic? They stick together. That means the velocities are the same. So we're going to have a 1.5 kilogram object with an unknown velocity of v. We're going to have a 1 kilogram object with an object of v.
Is that be negative or is it?
What do you think? Or would somebody else like to answer that question? It's a good question. Why? No, we don't know anything about the direction yet. So, okay, because it's mass, so just because it's mass?
Because we don't know the velocity.
Actually, it's okay. Closest to Zoe, even though she doesn't know the reason why. Because it's mass. Mass is a scalar. We cannot have a negative mass. So our direction might very well be our velocity could be negative, but not the mass.
No, I said velocity.
But we can't make these numbers negative on the right hand side right now. You see what I'm saying?
No. It's just a variable.
Right now it's just a variable. We don't know what the value is. No, it's a good question. It's a good question. I'd be wondering that myself, considering I just made us sit here and stare at the board until we figured out that the 20 was supposed to be negative. So you are right. It could be a negative velocity. We just don't know that part yet. All right. We do know that these two, the 1.5 and the 1, that those are masses. So they can't be negative. All right. So maybe that velocity is negative, but we have to do the math to figure it out first. So 1.5 plus 1 gives us 2.5. And it's 2.5 V, right? We add like and like. So they add up together. These guys, before and after, are equal to each other. Solve for V. Whoops. Solve for V means divide both sides by 2.5. And would you look at that? It's negative. So yes, it is a negative velocity in this case. Just a negative 2 meters per second. Okay. Now the lesson on this is that if you have two objects that collide, they stick together, the final momentum will be in the direction of the biggest initial momentum, right? Because the 20 times 1 had this was a bigger initial momentum magnitude than this one. So that's why it's going that way. Okay. So give me a second.